Hello, everyone. Welcome to the Dome9 webinar on how to prevent subdomain takeover in the cloud using Dome9 GSL. My name is Thelen Blum, and I will be your host for today's webinar. I'm the Senior Product Marketing Manager at Dome9, and I'm here with Ophir Ziegelman, Product Manager for Dome9 Security. A couple of housekeeping notes before we get started. This webinar is being recorded and will be made available on the website afterwards. All attendees are in listen-only mode. We will close with Q&A at the end of the session. If you would like to ask a question, please type it in the questions window of GoToWebinar, and Ophir will address as many questions as possible, time permitting. We have also uploaded 2 reference handouts, which include our Dome9 ARC platform and Dome9 Compliance and Governance product briefs. Feel free to download this content at any time during the webinar. I want to present a little background on Ophir before we get started. Ophir Ziegelman is a product manager for Dome9. Ophir has 10 years of experience in enterprise networking, cloud solutions, and data security. Prior to joining Dome9, Ophir was a systems architect at Imperva, working on their Secure Sphere web application firewall. Ophir's career also includes working as a software engineer, leading the development of a new social networking solution and interfaces for CRM applications. At Dome9, Ophir is responsible for leading the product management of the Dome9 ARC platform, leveraging his technology background to improve product capabilities and provide solutions to assist with growing challenges in public cloud environments. Ophir holds a Bachelor of Science degree in Computer Science from the Israel Institute of Technology. Now we will launch into our webinar discussion today. What does Uber and the Trump Organization have in common? These 2 companies have had their subdomains hijacked, but they're not alone. How quick and easy is it to experience subdomain takeover? You would be surprised. A simple misconfiguration in your network security can leave your organization vulnerable and exposed. How can your business stay vigilant and protected as your cloud environment continues to scale? In this 45-minute webinar, we will present how a subdomain takeover can occur in 15 minutes or less, the proper way your subdomain should be managed, why decoupled resources can become a launchpad for a hacker's malicious attacks, and how the Dome9 Compliance Engine with Governance Specification Language, or GSL, can help you uncover hidden vulnerabilities and remediate any misconfigurations to keep your subdomains and cloud environment secure. This presentation will include a demo of the Dome9 Compliance Engine and use of GSL. Without further ado, I will now pass the ball to Ophir. Let's get started.
So hello, everybody. Thank you for joining us. So thank you, Thelen. And let's start talking about how to prevent subdomain takeover. So subdomain takeover is a serious vulnerability. It could cause you quite many problems, and let's see how we can tackle those. So first, I must say that the subdomain takeover can lead to serious breaches. So obviously, when an attacker is taking over a subdomain and replacing the original resources, it could lead to serious flaws in the application, could lead to data leakage, and sometimes to credential takeover and other types of vulnerabilities. And it could also lead to serious phishing attempts. So there is a lot of difference between phishing attempt on your site where you replace the domain, and subdomain takeover will show the differences between those. And it could also be very hard to detect. So when it comes to subdomain takeover, this is a hidden vulnerability. And sometimes, as in the Trump Organization, it could even take years before someone noticed that this subdomain was taken over. So it means that anything from a few hours to few days or few years, and you can have this vulnerability quite over there until it's detected, and we'll see why it's so hard to detect. So before we continue, let's talk about what is a subdomain and how the takeover takes place. So first, let's talk about subdomains. So let's say that you have an enterprise that is using some domain, let's say example.com as the primary domain, and each subsystem is assigned with its own subdomain. So for example, the website is usually served from www. The shop is served from a specific subdomain. Static resources like documentation and other types of images and content can be served from different subdomains. And today it's very common that you have also a mobile site like m.example.com. And let's see how it looks on AWS. So on AWS, you have Route 53. Route 53 is the Amazon solution for domain and DNS service. So you can have it mapped from the domain can be mapped from Route 53 to dynamic content directly or via CDN. So you can serve the content coming from web servers so it could be like the online shop or the store. And then you can have static resources. So you can map Route 53 to serve content coming from CloudFront, which is the Amazon solution for CDN. So it could do all the caching and content distribution coming from resources like S3 bucket, and you can have it mapped directly from Route 53 to an S3 bucket serving dynamic content. So this is a screenshot example of how you see this mapping done on Route 53. So you can see that you have different types of records. You can have NS and SOA and CNAME and also A-type records, each one mapped to the specific subdomain. And you can see that, you can see here that it's mapped to a specific resource like this specific this specific S3 bucket that serves the content for a shop or whatever. So now let's talk about what happens when something goes off. For example, you have a Route 53 DNS entry that is mapped to an S3 bucket, and then someone for some reason changes the bucket or deletes it. It could be because of architectural changes. It could be because a mistake happened and some script runs and someone deletes this bucket. And no one handles the corresponding record on Route 53. So when you browse to this specific record, you see that you have a resource not found. So you get an HTTP 404, and you can see all the details of the bucket that is missing. So this is what is called resource decoupling, and this is the source of the problem that I'm talking about in this webinar. So now, when the attacker discovered this resource decoupling, comes the subdomain takeover. The attacker sees this decoupling, so you had the original S3 bucket, and then someone deletes it, so the link between Route 53 and the bucket is deleted. The attacker can just go to his own AWS account, create an S3 bucket with the same name. So one of the major vulnerabilities that you can see in here is that S3 can be duplicated. It's the name of the bucket, so you can just create a bucket with the same name after it was deleted on a different account. So this is what happens, and you can see that you are serving now malicious content coming from your Route 53 serving malicious content on a different type of account. So now let's see the demo, how it looks like when the attack goes on. So here you can see this is my AWS account. You can see that I have a bucket called Dome9 demo web.dome9.com, and I have a static resource. It's an HTML file, and it serves the legitimate content. Let's see how the Route 53 configuration looks like. So I have the hosted zone. You can see my domain. It's called Dome9.com. And when I go inside, you can see that I have a CNAME record called Dome9 demo web.dome9.com. And you can see that it is mapped to the public DNS entry. It's a CNAME type of entry, and it's serving the content coming from this specific bucket. So now we can just go to this address. We can just type in the address, and you can see that, yeah, it's coming up. So you can see that I'm serving legitimate content coming from my own domain. So now let's see what happens when someone deletes this bucket. So let's go to S3 Management Console on AWS. Let's find this specific bucket that we have and delete the bucket. So we have to type the name of the bucket to make sure that we want to delete it, and then it's gone. So now if we go to the browser and refresh the page, you would see the error that is coming up. So you can see that it's a 404 HTTP 404 message. You can see the exact code that is coming up, no such bucket, so you understand that there is a resource decoupling, the bucket is missing, and you can also see the exact name of the bucket that was deleted. So now, as an attacker, I want to exploit this. So we come to the second part, which is the takeover. So when it comes to the takeover, as an attacker, I actively search, or by mistake, I find this type of decoupling. I go into my attacker account. It's a different AWS account. I copy the name of the bucket that I want to create, which is the same bucket as the one that is missing. And now I create the bucket that I want to serve. So I have the bucket. Now I want to make it public bucket that serves static content. So I go into the console, make it a website, static web hosting, and I can go back and upload the resource. So I just add a malicious file. It's a file that serves the malicious content. We can even make it public. We upload a file, and let's make it public in here. Done. So now we can just go to this. We can refresh, and you can see that I'm serving malicious content coming from the same domain. So you saw how simple it is to take over a domain once this decoupling happens. So now you can understand why it's so dangerous. So we talked about phishing sites. So when it comes to phishing sites, the attacker tries to spoof the website URL. So instead of using the actual name of the site, obviously they can do it, they try to mimic the site name and use something similar, like Amazon with double N, or similar mistake that people may not notice, and serve similar content. But if someone sees this specific URL, and there are many solutions that show how this is done, they can just block these types of attacks and take down the domain. When it comes to subdomain takeover, the original content is still served, but one of the subdomains is still malicious and is serving malicious content. It is almost impossible for you to detect such an anomaly, and you don't know what is happening behind the scenes. And you see some of the resources that are serving malicious content, and you may never know that it happens. So this is why it's so problematic. So let's talk about detecting subdomain vulnerabilities. When you want to detect subdomain misconfiguration, you can do it by yourself. I mean, this you can write your own scripts that do this type of detection. The problems are that services today tend to span over dozens of cloud accounts. We see our customers using sometimes 100 accounts, even more, and detecting such misconfiguration across so many accounts, it's not very easy task. Many times you have so many mapped resources, you have so many types of resources that you need to discover. And like I said, you need heavy scripting. You need your security team to have development skills. Not all the security teams have this skill available. You need to run these scripts periodically. You need to have all the privileges that you need to assign to this specific script, and you must write your own script for different types of mapping. So if there are many vulnerabilities of that kind, and it's not very easy to write all those scripts. So let's see the Dome9 of how we are going to detect these types of misconfigurations. When you use Dome9, this is a screenshot of how the Dome9 Compliance Engine looks like. So we have a lot of bundles that shows different types of rules. We can see it later how it's on live demo, how it looks like. And you have rules like you can see in here. I created a dedicated bundle of rules that holds a single rule, how to find decoupled S3 buckets. So let's see how the rule looks like. We're using a specification language, a query language called GSL, Governance Specification Language. And you can see the syntax that I use to discover this type of vulnerability. Let's organize this query so you can understand what happens in here. So I just restructured the same query, and you can see that now you can understand what are the different parts of this query. So first we have the entity that we're testing. So we're reasoning on root 53 record set group. We have a filter and we have a test. So our filter is basically aiming to find only to limit specific types of records. We have CNAME type record, and we want it to contain asset metadata. This is the asset that the rule points to of type S3 bucket. So there can be many types of records. You have A-type records and so on. We want to limit this only for CNAME, but obviously you can write whatever you want. And now we want to make sure that the assets exist. So we say this specific type of record sets should not have record sets with records that point to non-existing data. So this is our syntax, asset metadata dot exist equals false. So this is it. By running this specific query in the Dome9 compliance engine, you get the output. You get a report that shows you all the rules that failed, and you also see all the resources that failed this specific test. So you can see all the information regarding these specific entities, and once you click on one of these entities, you get what we call entity inspector. So this is basically an object, a JSON object that shows you all the different fields that we get from Amazon. You can see the name of the domain, you can see the name of the record, and you can see all the information that you need and start the remediation process. So you can run this specific rule on all your accounts, and you can run it continuously. So whenever there is resource decoupling, whenever someone deletes this specific deletes an S3 bucket that is mapped on Route 53, but no one deletes this record, you can always get the notification that tells you something is misconfigured. So it's very easy, it's very intuitive, and you can do your own modifications. Now it's time to talk about how we finish the detection. Now we want to fix the problem. So fixing subdomain takeover is very simple. There are two main possibilities for you to do the remediation. The first one is remove the record. So you can just go into the AWS console, and then you can just delete the DNS entry that points to basically nothing. The other option is just edit the record and point it to another resource. It means that whenever you have, if someone by mistake it deletes this S3 bucket or any other type of resource, you can just go and point it to another resource just so nothing fails. So editing the rule also solves the problem for you. It's as simple as that, and you can see that both the detection and both the and also the remediation is very easy for that type of vulnerability. So this concludes our demo on this specific topic. If you have any questions, go ahead.
Okay. Ophir, it looks like we have a few questions. The first one is, you presented Route 53 vulnerability with CNAME records and S3 bucket. Could similar vulnerabilities exist with other types of decoupled resources?
Yeah, absolutely. So I started talking about it, and definitely it could happen with different types of resources. It could be mapping issues between Route 53 and CloudFront. So if you map your Route 53 to serve content coming from your CDN, and someone deletes this specific CDN instance from Amazon, the same vulnerability can happen. It's not as easy to take advantage of as in S3, but it could happen. Same thing could happen between CloudFront and S3. So if you map your CloudFront to serve content coming from S3, then if someone deletes this bucket, again, the vulnerability happens again. And like I said, it doesn't have to be only CNAME type of record. It could be also a record or any type of other records, but again, it's not as easy to take advantage of.
Okay. Second question we have, can the Dome9 Compliance Engine check for additional Route 53 misconfiguration issues?
Yeah, absolutely. So let me just open my the Dome9 console so I can show you this. Like I promised, let me show you this. So this is the Dome9 console. This is the compliance engine, and you can see here that we have a lot of bundles. We just you can see that we have a network alerts, And these are the rules that we are running. So we have, this is a network alert, so you can see a lot of best practices that we have for detecting different types of vulnerabilities. So you can see that for each rule, we have description of the rule, we have the remediation, and we have the GSL, the query that Dome9 engine runs, and you can see that we have different types of bundles. We have bundles for CIS and HIPAA, and we just released, this week, we released GDPR and NIST. And if you want to experiment with the different types of element that we cover, you can go into the playground and see all the different elements that we have. So if we go to the rule builder, you can see that we have a very intuitive UI that you can do. You can basically build GSL queries step by step. So we can go into these different types of elements. I picked root 53 record set group, and you can see all the different elements that we serve in here. So one thing that we can do, for example, is we can say that root 53 record set group. Now we can say should not have record sets with type A. So if your organizational policy say I don't want any types of, sorry, it should not have, yeah, with type equals A. So you can see this is a very simple rule, and you can just say I don't want any records of type A to exist in my my DNS records, and you run this on your account, and you can see the exact solution. Oh. Yeah, so it should not have contain type equals A. Okay, so here you can see exactly what can be what complies with this rule and what does not comply, and you can go into these specific entities and see exactly why they don't comply. So you can see that this specific one has record set of type A. In a similar manner, you can also say, okay, I don't want any type CNAME or whatever, so you can just browse on all the different attributes that we have. You can also check our root 53 domain. So we added this entity a few days ago, and you can see that just in the same way, you can just see all the different types of attributes that we have, like expiration time, automatic renewal, and so on and so on. So you can just build your own specific queries and run them on your specific accounts, find your own vulnerabilities and things that do not match with compliance or with your organizational policies, and run them in the compliance engine. That's it. Yeah, Talon, do we have any more questions?
We do. We have another question. The question is, you show the compliance engine. Is Route 53 part of compliance requirements?
That is very interesting. So I'm not a compliance expert, but Route 53, as far as I know, does not appear on specific compliances, so they don't refer specifically to Route 53. However, they do refer to business continuity. So if the compliance requires your business to be always online and you should have different types of solutions to recover from disaster and so on, obviously things like domain expiration could lead to outage. And there are many things that you can do. So first, if you're using AWS Route 53 to manage your domains, then you can write things like Route 53 domain should have auto renew equals true. So in that way, you basically make sure that you don't forget to renew your domain. In that case, you see that I enabled automatic renew, and you don't lose your domain. In a similar way, you can check, if you don't have it, you can check for expiration time by yourself. So you can say things like Route 53 should have expiration time after, let's say, 30 days. So when you run this specific query and your domain is about to expire within a month, then you say, okay, it's time to renew my domain, and you do whatever you need to renew your domain. So to sum this up, business continuity is one of the requirements for many compliances, and you need to make sure that your business remains online even if disaster happens. And this is also the way for us to make sure that our business remains online, even if we're using DNS services such as Route 53.
Okay, Ophir, it looks like we have a final question. What sort of data input does the Dome9 Compliance Engine require? Do we need to supply our company's DNS records, or does Dome9 already enumerate all misconfigured S3 buckets in AWS?
Yeah, so Dome9 is working with AWS APIs. So you just do a simple onboarding. You give us permission to look at your cloud accounts, and when you give us this permission, we just pull this information. It could be in read-only mode, so we have only access to your metadata. We don't have access to your private data. But things like domain metadata, the name of the domain, and all the configuration that you see in here, like automatic renewal and stuff like that, are part of the metadata that Dome9 gets from your AWS accounts, and you can and we start processing this. So the more accounts that you give us, we can just do all this calculation across all your accounts and find the vulnerabilities that are out there.
Great, thank you. That concludes the Q&A section of the webinar. Thank you, Ophir. All right, everyone. This concludes today's webinar. Thank you for attending. If you have any further questions on the information presented today, please don't hesitate to reach out to us via the email q&anda@dome9.com. I have a few final notes. If you enjoyed the webinar presented today and would like to experience the Dome9 ARC platform for yourself, we're offering a 14-day free trial. Please visit our website at www.dome9.com and click on the Get Started button on our home page. Just register, and a representative from Dome9 will contact you to activate your free trial. Additionally, if you liked the webinar today and would like to hear more about the multi-cloud security and compliance solutions Dome9 provides, please feel free to visit our resources page on our website and sign up for several of our upcoming webinars, or go to www.dome9.com/webinars. If there's a topic you would like us to discuss, please contact us through our website and let us know. Additionally, Ophir has just written a blog posting about preventing subdomain takeover. Please feel free to take a look at it on our website. Again, go to the resources section and you'll see a drop down for our blogs. Click on that and you can see the most recent postings that we have that would be helpful information. With that, we thank you for your time today and hope you found the content informative. This now concludes the Dome9 webinar. Enjoy the rest of your day.